Hello and welcome back. This is AG3 CH4 Video1. Today we're looking at how can you multiply and divide square roots. Let's begin with some review of some vocabulary. So a radical, it is the symbol of the square root or the cube root or the fourth root. That is the radical. It can be also anything up here where the place of the n root. The n is the root that we are taking. So it can be the fifth root, the sixth root. Any number can be placed here, and we can even have fractions placed there, which we'll talk about later on. So it's the root that we're taking. So the fourth root of 16 is asking what number times itself 4 times equals the 16. And so that's going to just take experience and some understanding. And so the answer is 2, because 2 times 2 times 2 times 2 equals 16. So the fourth root of 16 equals 2. The radicand is anything under the radical. So in our example, the fourth root of 16, the radicand is 16. So it is this part right here. That is our radicand. It can be a number, it can be a variable, it can be multiple things in there, but it's all the things underneath the radical. Okay. A radical expression is an expression that contains a radical. An example would be the fourth root of 16. That can be a radical expression. So when we have a radical expression, I ask you to give it to me in its simplest form. There's 3 things that have to happen. There could be no radicands that have perfect n powers as factors other than 1. And we'll look at an example of what that means here in a moment. There can be no radicands that contain fractions. That means nothing underneath a radical can be a fraction. And no radicals appear in the denominator of a fraction. So all 3 of these things must happen when I ask you for the simplest form. Let's look at a rule. A product property of square roots. This states that the square root of a product equals the product of the square roots of the factors. So let's look at what this means. Our example is the square root of 45. So 45 is not a perfect square, so we cannot take the square root of it and have it to be a nice whole number. But if we notice, 45 is equal to 9 times 5. 9 times 5 equals 45. So that's not really changing anything. But the square root of a product equals the product of the square roots. So we're taking the square root of the product of 9 times 5, of 9 and 5, which means we're taking the square root of 9 times 5. We can separate these 2 out. So now we have the square root of 9 times the square root of 5. This is okay. This is a rule that we can do. We can separate them. And now if you notice, the square root of 9 is a nice whole number. The square root of 9 is 3. We write that. The square root of 5 is still not a nice clean number, so we just keep it in the symbol of the square root of 5. So the square root of 45 ends up being 3 square root of 5. The way we say this is 3 root 5. Let's look at another example. We're taking the square root of 108. If we put that in our calculator, it's not a nice pretty number, but through some practice we find that it's equal to the square root of 36 times 3, because 36 times 3 equals 108. 36, however, times 3, we can separate to the square root of 36 times the square root of 3. The square root of 36 is 6, which gives us a nice whole number, and we keep the square root of 3. So we get the answer as 6 square root of 3. You may hear this being said as 6 root 3. One last example. If we're taking the square root of 9 times x cubed, through experience, I know that I can take and separate the x cubed into x squared times x, because really x cubed means x times x times x. This is x times x times x. So we separate this all out. The square root of 9 times the square root of x squared times x. We separate this out again. We get the square root of 9 times the square root of x squared times the square root of x. But we know the square root of 9 is 3. This is asking what times itself is x squared. Well, that's just an x. And we keep the square root of x. This one is a little bit more, let's say, just going to take some practice getting comfortable with, where we can pull out these x squares, and whenever we can take out a square and take the square root, it's just whatever's underneath. You need to be familiar with this because we're going to be seeing this in our assignments and as we move forward. Okay, so today's assignment. Now, this video has an assignment, so you should be working on the assignment. Our assignment, AG3 CH4 Video1, is to simplify the expressions. So I want you to practice doing what we did here. We want to break this down, the square root of 24, which is not a perfect square, into two numbers. One of them is a perfect square. Similarly here, square root of 80 into two numbers, one of which is a perfect square. You may have to look at our last example for 3 and 4. Okay, go get the practice.